we're going to look at complex numbers. These numbers aren't imaginary like your best friend from when you were 3 and 4 years old. That's not what they mean when they say imaginary. What they mean is, it was really just an unfortunate choice of words, imaginary. They're more complex, which is what they're called now more than anything. An imaginary unit is called I, and I is equal to the square root of -1. Now, under normal circumstances, why would the square root of -1 be impossible to find? You can't take the square root of a negative. Why can't you take the square root of a negative? Exactly. Squaring something means that you multiply it times itself. And if I multiply like a negative times a negative, it's going to equal a positive. Positive times a positive equals a positive. What do you have to multiply in order to get a negative? Right, you have to do opposite numbers, two different numbers, two different signs. So that's why it's impossible. Well, I don't know, maybe 200-300 years ago, some mathematicians, and it was actually like two mathematicians working independently. They just happened to be working on the same thing. It's kind of amazing that it happened that way. But they started seeing that there were actually applications. If we could find the square root of a negative, there were applications to using it. So they came up with this, and they called them imaginary. And that's how we came up with the square root of -1 is I. Okay? Like, square root of -36. We could split that up, because we know that the square root of 36 part is 6, and we know that the square root of the -1 part is I, so the square root of a -36 is 6I. Square root of -25 would be 5I. And anytime you see that I stuck on something, then you know, hey, that started out as the square root of some negative number. And you can even simplify. Like if you have the square root of -18. Well, 18 doesn't have a square root, but I can break this down to -1, 9, and 2. That has a square root, right? What's the square root of -1? I. What's the square root of 9? Does 2 have a square root? No. So it has to stay inside. But the square root of -18, 3I, square root of 2. Okay. Usually we write the I in front of the radical sign, just so you know. Some people write it behind it. I'm going to suggest that you do not do that, because it does not go under the radical, and some of you get crazy with your writing. Is that in or out of the radical? Who knows? It's like half in, half out. Don't do it this way. Go with that one. That one. Alright, let's see. Now, a complex number is a number in the form a plus bi. A plus bi, where a is the real part and bi is the imaginary part. Here's something that most people don't realize because we can't introduce, imaginary numbers are so high abstract thinking, we can't introduce them early, but every number that you use is actually a complex number. What was the one that you said? 6i. 6i is a complex number. And say, no, it's just imaginary. There's no a part. Well, if I put 0 plus 6i, there's my real part, there's my imaginary part. So it is a complex number. It's a complex number with a real part and an imaginary part. You say, well, what about all those numbers I learned like in the first grade? No one ever said anything about imaginary then. Well, 12 plus 0i. There's a real part, there's an imaginary part. So it's a complex number. All numbers that we study are part of the complex number system. And then from the complex number system, it splits into real numbers, imaginary numbers. And then real numbers split into rational, irrational. Because rational goes down to integers, whole numbers, counting number, all that fun stuff that we did. Okay? So every number is a complex number because you can always add 0 amounts of the other one. Complex numbers have properties. You can add and subtract complex numbers. When you add and subtract them, you add and subtract the real part to the real part and the imaginary part to the imaginary part. So if you have 7 plus 3i plus 4 minus 10i, I'm going to add 7 plus 4, real part to real part, and 3i to negative 10i. That's going to be my answer.
So when does this get harder? I know it's going.
It's not going to get that much harder, actually. We're going to, well, let's do a subtraction. Some of you are going to forget this. Let's say instead that was 7 plus 3i minus 4 minus 10i. That's 7 minus 4, 3i minus negative 10i, and that's your answer. You can also multiply complex numbers, but before we multiply complex numbers, we need to talk about the powers of I. I'm going to give you a second to get that written down, and then we'll talk about the powers of I. And this is actually, we're doing this in Algebra 2 right now, so these shouldn't be like brand new, completely, I've never seen these before, right? You've seen this. Yes? Some of you are saying yes, some of you are saying no. Alright, powers of I. We're going to say that I equals I, reflexive property. I equals I to the first power, anything first power equals itself. But let's talk about I squared. Now if I equals the square root of negative 1, what happens if I square that? It's just negative 1. Because what happens when you square a radical? Yeah, it's whatever's inside there, right? So that's I squared equals negative 1. Now we're going to use these two to answer a whole bunch more. I to the third. Alright, I to the third. I'm going to split that up into I to the first power times I squared. Because if I multiply these together, the 1 and the 2 are going to equal to 3, right? So what's I to the first power? I. And what's I squared? -1. So I to the third equals a negative I. Alright, ready for another one? Let's do I to the fourth. I'm going to break that up into squared times squared. The squared times squared would be the fourth, right? What's I squared? And -1 times -1? +1. Okay, let's keep going. I to the fifth. Now, since that's 1, I'm going to try and use 4 as much as I can, because does multiplying by 1 change anything?
No.
No? Okay, so let's say that's I to the fourth times I to the first. What's that going to be? I, okay.
Oh yeah, this is
I do. So what's this one going to be?
minus. This is what I love about it.
It's going to be -1.
It's going to be I minus 1, I minus I, 1.
It's going to be negative I. So what's this one going to be? 1. How often do they repeat?
Eternity.
Every 4. Okay, so what if I had I to the 99? Like, I don't want to go through that 99 times. What can I do instead? What? Divide by 4, okay? Do I care about the answer? What do I care about? The remainder, yes. 99 divided by 4. So if the remainder is 3, what is I to the 99th equal? Negative I. Yes. Okay. This right here needs to be memorized. You need to memorize that.
So as long as you have the first 4, you know all of them.
Yes, because they keep repeating. If you know the first 4, you know them all. Divide by 4, you look at the remainder. Because all these powers of 4, it's going to be 1 times 1 times 1 times 1. Doesn't change anything. Yeah. All right, now let's multiply. Let's multiply some complex numbers. We're going to use distributive property. Everything gets multiplied. 3 times 2. 3 times 5i. 15i. Negative 4i times 2. And then negative 4i times 5i. Negative 20i squared. Alright, so now let's simplify this. These two are like terms. So it's going to be 6 plus 7i. Now what happens with this? What's I squared? Negative 1. So this is like a negative 20 times a negative 1. So what's going to happen here? It's going to go to plus 20. And my simplified answer is 26 plus 7i. Okay, I'm going to leave that one up there. Let me give you one to try. Okay, what's 5 times 2? 5 times negative 3i. 2i times 2. 2i times negative 3i. Alright, when I simplify it, what does it become? 10 minus what?
11i.
I don't know. I didn't do anything wrong with it.
Very good. We're going to divide on today, not by tomorrow, but that's pretty much it. Even division is really just multiplication. So it's not that bad. It's like fractions. Just on this?
Yes. Yes.
Just on this.
Yes, okay. Hang on, let me give you one more.
Help me get my groove.
Try that. This will be our last one. Last one. Alright, let's see here. I've got 25 minus 15i plus 15i minus 9i squared. Those go away. I end up with 25 plus 9, which is 34. Very good. Very good. Alright, just adding, subtracting, and multiplying today.